Hello everyone and welcome to the channel. I was trying to show you the hands-on demo of this mixture of expert model from Microsoft. This one I'm talking about, but unfortunately it is way too big for even A100 GPU, which I tried it on and it was just giving me out of memory error. So instead of hands-on demo, I just thought of giving you a run through as what this model is because the model's capabilities are quite good and it is at par with the one which we already have seen, this Phi-3.5 Instruct one, which is quite, I would say, performant in terms of quality of responses, reasoning, and logic. So in this video, I'm going to run you through this mixture of expert instruct model because the reason why I want to do it too is that we thought that maybe mixture of expert model architecture is really dead. It all started with a Mistral last year, and there was a lot of talk about it. People were thinking that it might just evolve into something new. But then a few companies released mixture of experts model, but then for the last 4 to 5 months, we didn't see any mixture of expert model coming through. So that is why I was quite surprised when I saw Microsoft releasing this mixture of expert model with Phi 3.5. Before I tell you about it, if you're interested to learn more about these models, how to get them installed locally on Linux, on Windows, Mac, and how to fine tune them, I already have done around 4 videos just in last 24 hours. So if you're interested, please go through them. I'm more than sure you won't be disappointed in terms of hands-on demo. And I also have done a lot of benchmarking and testing on various prompts and benchmarks for all of these models. I already have done a video on this Vision Phi 3.5 model, which is very cool. I would highly suggest you to check it out. Now, coming back to these Phi 3 models, Microsoft has done really wonderfully well with this new family of models featuring three variants: Mini Instruct, which is 3.8 billion parameter, Vision Instruct, which is 4.2 billion parameter, and then this mixture of expert, which is 42 billion parameter model, and that is the topic of this video. This model is also MIT licensed and supports up to 128K token context like other of its brethren. It is available on Hugging Face, as you can see here, or even you can get it from Azure's AI Studio. This has been trained on 4.9 trillion tokens, including 10% multilingual content, but its multilingual capabilities are really excellent, as I have seen in other models. The model is intended for commercial and research usage in multiple language. Performance metrics tell a really good story about this mixture of expert model with average score of 69.2 on 21 benchmarks, which is really awesome. Now, before I move forward, let me try to explain in simple words as what exactly is meant by mixture of expert model and how it works. So a mixture of experts or MOE is a model that divides an artificial intelligence model into separate sub networks or experts, each specializing in a subset of the input data. This allows the model to jointly perform a task while reducing computation cost during pre-training and achieving faster performance during inference time. Mixture of expert architecture enables large-scale models, even those comprising many billions of parameters, to greatly reduce computation cost during pre-training, and it achieves faster performance during inference time by selectively activating only the specific experts needed for a given task rather than activating the entire neural network for every task. Mixture of expert model can achieve greater efficiency while maintaining the performance. Now we know what is mixture of expert model. Let's see how it works. Mixture of expert models process data by designating a number of experts, each its own subnetwork within a larger neural network, and training a gating network or router to activate only the specific expert best suited to a given input. This allows the capacity of the model to be increased without a corresponding increase in the computational burden required to train and run it. By enforcing sparsity, mixture of expert models can achieve greater efficiency while maintaining performance. This is particularly useful in natural language processing tasks where LLMs can be scaled up while reducing computational costs. Mixture of expert models have been successfully applied to computer vision tasks too and remain an area of active study. But this is what I was referring to, that for the last few months I didn't see any mixture of model coming through, and now Microsoft has done it with its new mixture of expert model. Specifically, if you're looking for any memory or compute constraint environment or latency bound scenarios, this model could be a good choice. The training of this model, the way Microsoft did it, is also quite interesting because they did the training for 23 days on 512 H180 gig cards, and they used 4.9 trillion tokens, which is quite good. The architecture is quite interesting for this Phi 3.5 MOE. It has 16 into 3.8 parameters with 6.6 billion active parameters when using two experts. The model is a mixture of expert decoder only transformer model using the tokenizer with the vocabulary size of 32K, and it is best for suited for prompts using the chat format. It's again a multilingual one. It supports languages from across the globe, including Italian, Arabic, Korean, Norwegian, Polish, Ukrainian, Swedish, Russian, Portuguese, English, French, and a lot of others. The training dataset include a wide variety of sources, including 4.9 trillion tokens, which contains 10% multilingual data. But despite of the fact that it has used publicly available documents filtered rigorously for quality, it has also used a textbooks like data for the purpose of teaching math, coding, common sense reasoning, general knowledge of the world, science, which means science, daily activities, and that sort of stuff. So all in all, um, to me, the model looks very much similar to the just a simple Instruct version, but of course with more parameters. I wish I could test it out. I'm just waiting for any quantized version of this model to come through, and then I will try to um, create maybe on Q8, which will be very close to this full precision model, and then we will try it out on various benchmarks. So stay tuned. I'll be making another video with a hands-on demo of this mixture of expert as soon as it comes through. I hope that you enjoyed it and now you know more than before that what mixture of expert is and why this is so interesting that Microsoft had decided to come up with it. Let me know what do you think. If you think of any other reason why Microsoft did it, then I'll be very keen to learn. Please share your thoughts in the comments. If you like the content, please consider subscribing to the channel. Thanks for watching.